Hi everybody, this is your instructional video for Tuesday, May 17th. So just a reminder for those of you who may have been gone yesterday, I am absent today. I've taken some HAL kids to their last competition for the year. And so you all are going to be watching the video and following the instructions in the video for your lesson today. Let's go ahead and take a look at your objective. So today I want you to be able to explain how carbon in a closed system cycles through the ecosystem. Okay, we kind of talked about it yesterday when we were reviewing the questions for the mid-unit assessment, how carbon cycles through, and you all were talking to me the other day about a cycle is where there's a repeated happening of something over and over and over again. And so let's put all of that together today. We're going to talk about the carbon cycle. And we're going to be working on two different activities. First of all, you're going to watch the video. We're going to work through selected activities in Matter and Energy and Ecosystems 3.2 and 3.3. I'm not doing everything because some of the things I think are repetitious. And we just don't have time to go through everything. So I just kind of cherry picked a couple things just to really highlight our unit and to get you ready for your test on Thursday. After you watch the video, you should make sure that you finish your student-generated model for photosynthesis, cellular respiration, and the carbon cycle. That'll be new today. Your models are due Tuesday. I would love for you to have them turned in by the end of class so I can get those graded when I come back. But for sure by 3:30 on Tuesday, they need to be done. This is not just filler work or busy work for me. It's important for me to look at these models to make sure that your models are correct, because you need to study these models so that you can redraw them on Thursday when you have your test. Okay, so it's important that you give me a chance to look at them and help you revise them if necessary. All right, let's go ahead and I'm going to have you guys log on to Amplify, and we're going to be in 3.2. And I'm going to pause here for a second. I'm going to let you guys log on to Amplify. While I do, while you're logging on, let me talk to you about something really quickly. So I'm in my kitchen right now recording. It's about 9 o'clock on Monday night. And so the dishes are in the dishwasher. So if you hear a humming noise, that's my dishes. I'm sitting here with the windows open, my patio door is open. We've got Highway 75. I live just right across the street from Plattsmouth High School. And so we've got that Highway 75 right there. And just recently there was like sirens and all kinds of, I don't know what is going on today. And semis trying to pull through. And anyway, the point of my rambling is this. Throughout the video, if you hear some weird noises, it's just life at my house. So I apologize. We'll just muddle through. I'm not going to stop and start the video based on wackiness that you hear. I'll explain it if it needs to be explained, and we'll just move on, okay? All right, so hopefully by now everybody's logged on to lesson 3.2. Let's go to your warm-up. So we've got this gorgeous, gorgeous picture of the Earth. And we read this prompt. It says, Gabriella read in the newspaper that the amount of carbon in the atmosphere is increasing and that humans are responsible. And she said, if carbon in the atmosphere is increasing, the total amount of carbon on Earth must also be increasing. So think about this. We've got abiotic, which is in the atmosphere, the air, and then we've got biotic, or the total amount on Earth. What do you think about that? Do you think if the carbon in the atmosphere is increasing, the total amount of carbon on Earth must also be increasing? Go ahead and respond with either agree or disagree, and then take a minute to write out a complete sentence or two explaining why. And I'm going to let you pause the video so that you can finish that. And when you're done, please make sure that you hand that in. Okay. So you're finished with the warm-up. I wanted to show you this. This is something that I pulled up. You guys had actually a article that you read over the weekend, and you turned that in. I didn't know if you knew this, but doesn't this look familiar to you? I think that was very similar to the graphic that was in your article. And I want you to notice where the source is. This is real information. This is real data from NASA. And it's talking about atmospheric carbon dioxide. And the location is in Hawaii. And so you can see from 1960, the amount of carbon dioxide in the air is increasing, and has been doing so for the last several years. Okay, cool. We've got a train coming. So there's that. Awesome. Okay, let me continue here. I hope you guys can hear me. When Gabriella was talking about her statement that if the carbon in the atmosphere is increasing, the total amount of carbon on Earth must also be increasing. It's not something that is a far-fetched idea. It's something that just people... Listen, here's the deal. There's a lot of controversy when we talk about global warming. There's a lot of controversy about whether it's actually happening. Are scientists really giving all the facts? Are they just isolating certain things? What's going on? And regardless of what side of the argument you're on, you cannot deny that there is more carbon in the atmosphere. Now, whether that is a result of human actions on Earth, like are we burning more fossil fuels and giving off more emissions? Or is this just a natural cycle that the Earth goes through every, several thousand years? That's to be debated. That I could understand would be a debate. But the bottom line is, Gabriella's argument, we need to decide if we've got some kind of a key concept that holds weight to that argument, in order to be able to understand what's called the carbon cycle. So let's go ahead and keep going in our slideshow, and then we're going to come back to this warm-up, and I want to talk to you guys a little bit more about it, okay? So, let me come back. So if you guys remember, we have a key concept number 3, and that says if one part of a system changes, then it's going to affect the rest of the system. So if Gabriella says, hey, I read this thing in the newspaper, and it says that the amount of carbon in the atmosphere is increasing, it is changing. One part of that system is changing, and so that means that the carbon that's found on Earth has to be changing too. It's two parts. It's like if you can imagine a seesaw. If one side goes up, the other goes down. And if the other goes up, the other side goes down. If one part of a system changes, it affects the rest of the system. So if the carbon in abiotic increases, then the carbon in the biotic matter has to decrease. And then just the opposite is true. If abiotic water or air, the carbon in abiotic water or air decreases, then the carbon in the biotic matter has to increase. This is going to serve you well today if you keep this in mind, and you just kind of, the word for this to describe this in science is called inversely proportionate. And basically it just means if one goes up, the other goes down. It's inversely proportionate. Okay, hopefully that makes sense to you. So let's come back to Gabriella's statement. Do you agree with it? I hope you did. And the reason why is because we've got a couple key concepts that show us, first of all, if there is a change in one part of the system, there has to be a change in the other. And then I've got 2 other key concepts I think that we can use to sort of hang our hat on the idea of carbon increasing in one area would cause a decrease in the other. So let's keep going. This continuous movement of carbon through an ecosystem is often called the carbon cycle. Now, this is another graphic that should be familiar to you. This was in your article that you read over the weekend. And if you're looking at it real carefully, we can see where the location of these different pieces is. We've seen it in the simulation. So I've got abiotic matter, and according to our sim and for the purposes that we've been using, that's the atmosphere, that's air, but it could be water, okay? This is air, and when we've got the sun, carbon will come into the producers through photosynthesis, okay? The producers make ESMs. The carbons that came from carbon dioxide are now in ESMs. And then when the consumers eat the producers, they get those ESMs. And so now the ESMs are over here. When the producers and the consumers die, they go down to the dead matter. And now the dead matter has ESMs. Okay, if we had decomposers, that would be over here too. So this is all the biotic matter. Now, we haven't really talked about this little piece right here. Anytime we burn fossil fuels, that gives off an emission of carbon. Okay, I'm sure you guys have heard about this before. People talk about pollution. They've talked about decreasing their carbon footprint. Electric cars are gaining popularity because we want to decrease our carbon footprint. We don't want to burn as much fossil fuel, because burning fossil fuel will release that carbon dioxide that's been trapped in the dead matter. So once that's released back into abiotic matter, now that carbon comes back up here and it's in the atmosphere. When we go through cellular respiration, producers and consumers give off carbon dioxide. We breathe off carbon dioxide. So we have this really great cycle of carbon and how carbon moves through the atmosphere, through an ecosystem from abiotic to biotic to abiotic to biotic. And this, you can see, is why it's called a cycle, because it's just continuing to go on and on and on. It repeats on and on. I included this model also because this is a really simplified model of the carbon cycle. And I included it because, first of all, you're going to have to draw your own carbon cycle diagram. And I don't want this. This is, in my opinion, not the easiest to understand. And it doesn't really look like a cycle to me. It looks like just a whole bunch of arrows, and then, unless you really truly understand what's going on, then you can kind of pick up where that cycle is. Now this one is a little bit easier to understand. We've got carbon dioxide in the atmosphere through photosynthesis that comes down to the producer. The animals will get the ESMs from the producers. So my carbon and the ESMs come over here to the animals, and then the produce and animals go through cellular respiration. We give off carbon dioxide, so there it goes back in the atmosphere. When animals and plants die, then here it is in the dead matter. That's going to go through decomposition, and then that gets released back into the atmosphere. So this is an easier understanding of how carbon moves from abiotic to biotic, back to abiotic to biotic. So what I'd like you guys to do right now is stop the video, go to your, whether you have a digital copy or a hard copy, I want you to flip the paper over on the back. And in the space provided, I want you to draw a model of how carbon is cycled through an ecosystem during the carbon cycle. So you're drawing your own model, but I want you to include carbon moving from abiotic to biotic, back to abiotic. And so use arrows to show me this, how it comes out of abiotic. Look at key concepts number 4 and number 6. They talk about, or actually number 4 talks about photosynthesis. Key concept number 8 talks about respiration. You've got a lot of tools to use, and there's no right or wrong here. Will you please do me a favor? Make sure that if you're just drawing symbols, that's 1,000% okay. But can you label for me so that I can see that you've got what I'm looking for? And again, I want you to include abiotic, and biotic. All right? All right, so go ahead and pause the video, finish that up, and then come on back. Okay, so now that you're done with your model, I want you to go ahead and jump over to lesson 3.3. We're skipping everything else in 3.2 and jumping ahead. And let's take a look at this one. It's called Looking for the Missing Carbon. And this is where we're coming back to the biodome, and we're trying to figure out what's going on. How come we've got some missing carbons in the decomposers, or missing decomposers? I'm going to jump back to amplify. and because I want to show you this warm-up activity. So I'm going to go to 3.3. Let's go ahead and take a look at this warm-up. So it says in chapter 2, you learned that the decomposer population in the biodome decreased. So we know that decomposers decreased, and that's why there wasn't as much carbon dioxide. Cool. This meant that fewer organisms were doing cellular respiration. As a result, less carbon dioxide was given off, so the amount of carbon dioxide in the air decreased. If the carbon is no longer in the air or in the abiotic matter, where could it be? So based on what we learned about carbon movement in ecosystems, which claim best answers the chapter 3 question? And I want you guys to choose either claim number 1 or claim number 2, and then briefly explain your claim choice. So pause the video and let's go ahead and finish up the warm-up. All right. We are not going to obviously be able to have a conversation about which claim that you chose. I'm just going to go ahead and move on and hope that you guys made the right choice. So let's move on, okay? If you think back to the law of conservation of matter that says that energy, or that atoms in a chemical reaction, atoms cannot be created or destroyed. Okay, so in other words, we can't have an increase in carbon in the atmosphere and not have it change someplace else. It can't come from nothing. Also, just very recently, we talked about key concept number 3 in this unit, how if there's a change in one part of the system, there's got to be a change in the other part. So if we're looking at what happened to the carbon that used to be in the air, claim number 1 says the carbon that used to be in the air is no longer in the biodome, so the total carbon decreased. That makes no sense to us whatsoever, because first of all, it's a closed system. Second of all, they don't just disappear. So if we look at claim number 2, that's the one that makes the most sense. The carbon that used to be in the air is now in another part of the ecosystem. It's moved from one part to the other part. So the total carbon has stayed the same. It's just now it's relocated. So we've got 2 new key concepts. I'm going to have you guys pull out your key concept graphic organizers and copy down. This is key concept number 9. And you'll notice that it's in blue right here. So this means we've got a new theme. And the theme for PB3 is carbon cycle. So I'm going to have you guys pause the video. And when you're ready, go ahead and play. All right, so key concept number 9 says, since carbon cannot be produced or used up, it cannot be created or destroyed, the total amount of carbon in a closed ecosystem does not change. Now, bear in mind, this is only true in a closed ecosystem. If we have an ecosystem that's an open ecosystem, then it's not that it's disappearing, it's just literally going somewhere else. So everything that we talk about from here on out in the biodome, that's why it was so important that that you all understood this biodome is sealed tight. There are no leaks. It is a closed ecosystem. So again, since the carbon cannot be produced or used up, the total amount of carbon in a closed ecosystem does not change. Key concept number 10. I'm going to go ahead and read it off. You guys pause the video when you're ready to start again. You can play it again. Okay, so key concept number 10. I would love it if you guys went ahead and used these arrows again, because we're talking about what I said before, the inversely proportionate. If one increases, the other is going to decrease. So if the amount of carbon in abiotic matter increases, then it's also going to decrease, the carbon will decrease in biotic matter. And then just opposite, if the amount of carbon decreases in abiotic matter, then it's also going to increase in the biotic matter. And tomorrow we're going to play a game, and you guys will understand with these tokens. You'll totally get it. It'll be a kinesthetic way for you to model the carbon cycle. You'll see that. Okay? All right, so obviously we can eliminate claim number 1 because it is not supported by key concept number 9 and 10. And so claim number 2 is the claim that we're going to argue, that the carbon used to be in the air in the biodome, but now it's in another part of the ecosystem. And so the total carbon stayed the same. Well, here's the problem. That doesn't answer the question. How come the decomposers are decreasing? You guys, a lot of you guys know the answer to this. You've already pointed this out. This is the last activity we're going to do, and you will understand what the failure was in the biodome. In the biodome. I need you to go back to our biodome files. It's our news stories. This was in the very first, it should be in Good Notes right now, but I'm going to take you back to Schoology. If for whatever reason you do not have these, and Landon Sayer, I know you don't have it, Kaylee, you don't have it, so I want you to go back to Tuesday, May 3rd, and the biodome files are right here. Go ahead and put these in Good Notes if you don't have them. And what I'd like you guys to do is spend a little bit of time, everybody. We've already read these. You have already annotated these. But I want you to go back, and it says that they want you to look at specifically biodome file number 2. Pay attention to these little sticky notes. And biodome file number 3, which is a list of recommended organisms. And I want you guys, after you're looking at these little sticky notes, see if you can figure out why the decomposers decreased, and ultimately why the ESMs, there were not enough ESMs, why the carbons were not able to get recycled back up into the atmosphere so that photosynthesis could take place again. Let me come back here to my slideshow. So let's read Dr. Corey's message about the files before you read them. He says, I've been reading through the biodome files to try to get a better sense of what went wrong in the biodome. You've been focusing a lot on decomposers in this chapter, so I left some notes in the files. I'd like you to look at these files again and use my notes to help you think about what might have caused the decomposer population to decrease. With any luck, we might be able to come up with a good explanation for the biodome's failure. A handful of you guys already know what's going on. If you know what's going on, just go ahead and jump to your last lesson 3.3, activity 3, and you can start writing. But if you're not really quite sure, go back, start looking at file number 2 and 3 where Dr. Corey left notes. Review the annotations that you've already made to find any evidence that indicate what caused the decomposer population to decrease. Okay? Then you're going to review the biodome files. It says discuss the evidence. I don't want you guys to discuss with each other. Just think about it. And then you're going to write a claim using the evidence that you found. Make sure you hand that in. I'm going to jump to amplify. This is the activity you're going to be in. It's right here, activity 3. Okay. And there is just a place right here where you're going to review the annotations. Based on your evidence, write a claim that can explain what caused the decomposer population to decrease. What was going on in the biodome that would cause the decomposers to decrease? And then describe the evidence that you found in the biodome files. How do you know? What evidence do you have to back up that claim? Make sure you hand that in. I am going to be reading these to make sure you guys understand why the biodome failed. Okay? Last but not least, when you are finished with that, I just want to make sure that you've got everything finished and handed in. Write an explanation for 3.3.3 and hand that in. If you've got time, you can work on key concepts and vocabulary. You can work on other homework. Or you may have noticed in your folder, I have a Kahoot for review. So I just wasn't sure if I gave you guys enough to keep you busy today. So here's that photosynthesis and cellular respiration Kahoot. We'll do a little bit more review tomorrow. Please make sure that you are studying and you're ready for this test on Thursday. Okay, you guys, I will be back at the end of 6th period. So if anybody has any questions, come on in during guided study and I'm happy to help you out. See you later.